Hi friends, my name is Erin Stellato and thank you for attending my session today from wherever you are in the world. I'm in the United States, so normally I would much prefer to be in London for this conference, but this will absolutely still be a great session for you today and you will have plenty of time to ask questions. So this is why you need Query Store. And in case you haven't seen me present before, this is my yay me slide. The most important thing on this slide is my email address, erin@SQLskills.com. You will have time to ask questions during today's session, but if there's something you think of later or you have a follow-up or maybe I don't get to it for some reason, please feel free to send me an email, erin@SQLskills.com. You can also reach out to me on Twitter at Erin Stellato for anything longer than whatever the character limit is today. Just send me an email. I'm also on LinkedIn and I work for SQL Skills and I'm a principal consultant as well as an instructor for our immersion events. And I am also a data platform MVP. Here's a little bit about the SQL Skills team. I like to mention the members of the team. Paul and Kimberly are the owners. Jonathan, Tim, and I are consultants. Sometimes I reference my team members throughout the session, so I just like you to know who they are. I've got information on this slide about the training that we provide, the services, the consulting that we provide, remote DBA. We speak at conferences such as SQL Bits, also the Past Summit and Intersection. If you want to hear from us on a regular basis, please let us know through our newsletter link. You can sign up to hear from us every couple weeks. And with regard to training and services, I have the links for those here if you want to learn more about. We are offering our immersion events online this year, and we would absolutely love to see you there. So please feel free to email me with questions also about either training or services if you have them. Here's our abstract for today. I'm not going to read it. I assume that you're here because you want to understand why you need to have Query Store in your environment. And this, I love Query Store. This is a topic that I can talk about for hours, and I do. And I can go really, really deep into this topic. However, we have 50 minutes. And a friend of mine reminded me that in 50 minutes, I can talk about the why, but I can't necessarily talk about the how. So we are going to really focus on the why. I will definitely show you some demos, and hopefully there's going to be enough to get you off and running. I know there will be enough to get you off and running. But I'm hoping that you will find this feature as valuable and just fantastic as I do. So just to frame how we think about why Query Store is so important, I want you to think about a scenario where the server crashed. Maybe that's something that happened to you recently, and if so, kind of pull that memory back into your head right now. Or think about a time where there was an issue and things were just kind of falling apart and you did a server restart. Or someone maybe comes in and they're like, hey, we're having an issue with performance. Can you take a look? And in the couple minutes that it takes you to get connected, all of a sudden, everything's fine again. So in those scenarios, if you think about this, what kind of data do you have after the fact? And we have the error log. The error log has sometimes a little bit of extra info in there, right? If you're not using trace flag 3226, for example, you're getting backup information in there, which to me is not error log type of info, right? I want to know what went wrong. So it's possible that we have information in the error log that tells us why something went on, but it's also quite possible that we don't. We also have system health, and we still have default trace. It's still there in SQL Server 2019, so that's an option. But depending upon what kind of problem we ran into, we may or may not have data related to that in system health or the default trace. And then we also have anything that you might have set up to capture information. And that does include third-party tools. And I'm going to talk about those a little bit later on with regard to Query Store, because I absolutely think that Query Store is still relevant. So depending on what you might have in place or might not, right, you may not be able to find what you need after the fact to understand why a particular problem occurred, or how to prevent it or address it. And this is the number one reason why you need Query Store. And I'm going to hop right away into a demo. And actually, let's do this a little bit different. Let's go this way to hop into that demo. Here we go. All right. Now, I've done a little bit of prep work here. And so let me go ahead and stop all this extra stuff that I have running in the background. And we're actually going to start in the UI. So within Management Studio here, let me just zoom in a little bit just so you can see. We are working with the latest version of SQL Server 2019. So this is cumulative update 6. It's the latest version as of the time of this recording. And if I expand my databases, I have a copy of the Wide World database here. And you'll see that underneath I have this Query Store, let me zoom in here, Query Store folder. And you're only going to see this folder if Query Store's been enabled. So if you log onto a server right now, if you're trying to multitask, and you are running SQL Server 2016 or higher, and you come in here and you look, and you don't see the Query Store folder, that's because it's never been enabled for that database. Once it's been enabled, we have a set of reports here. And most of the time, where I start is this top resource consuming queries report. So we'll jump into that. And I'm going to orient you to this window because this is where I spend a lot of my time when I'm troubleshooting. So first of all, you'll notice that this is going to, by default, give me the top 25 resource consumers for Wide World importers for the last hour. So by default, it's just going in by duration, by specifically, if you look underneath here, by total duration for the last hour. That's the default. Now we can change this, but just so you know, that's where you come in to this view. Now, we have a nice visual here, and that we can see, if we look at the bar graph, that we have a query that's really taking a lot more time in total than some of the other queries that are running right now. And if I hover over that bar and I zoom in here, you'll see that I have the ID for the query, and I have the object ID, and I have the object name. So one of my favorite things about Query Store is it ties the queries to the object, assuming they're not ad hoc. So when I have a store procedure and I have 50 queries within that, all 50 queries exist individually within Query Store, and they're all tied back to the object ID for that store procedure. So it makes it really easy to look at performance across an object, right? But here's the query in question that seems to be taking a lot of time today. And this is great. I'm looking based on duration, but you can see I also have an execution count, and this is fun. I also have a plan count. So this first view that I start with here, this is what it always defaults to, and this graphic gives me, this bar chart on the top left here, gives me an idea of what really is standing out. And it doesn't always look like this, right? Sometimes you just see straight things across the board. Sometimes there's a ton of skew. But I like to go into also this grid view. So up here in the top, we have this button, which is the option to view these queries, view this information in a grid format, which I much prefer after I've done this initial view, because then I can see information like the object name, the text of the query, in a little bit more readable format. So I'll zoom in here so that you can also see this, right? So we haven't changed how we're looking at anything, right? It's still total duration. But now I can see the object to which the query belongs. I can see the text of the query. I've got duration information, execution count, and again, plan count. And I'll tell you, plan count is, I think, incredibly valuable, because if you think about the situation that I described earlier, where I said, what happens when somebody comes in and they're like, hey, there's a performance issue. You get connected, you start to look, and then they're like, it's gone, things are fine now, don't worry about it. And you're like, but what happened, right? What was going on? And if you look in the plan cache, you're not probably going to see what's going on after the fact, because that plan no longer exists in cache. And that's one of the toughest things, I think, when troubleshooting. Because that plan cache is transient, I don't have that history. Now I do have it within Query Store. So on the top left, we have the query itself and some of these metrics. On the right, this view which has these circles in it, this is information about the plan for that particular query within that window of time. So remember, we're looking at things for the last hour. So down here across the bottom on this x-axis, you'll see that we've got 12:14 to 1:14. So this is plan performance over time. And I'm going to be very specific there. It's not query performance. It's plan performance, because for any given query, we could have n number of plans. Maybe it's one. In this case, it's two. So you'll see over here on the right, I've got this plan ID box. And I have plan 8284, and I also have plan 8448. Now they have different colors to make it easier to see on the graph. Those colors are just, they'll change, right? If I close this and reopen it, it can be different colors. That's not what matters. The ID matters, and the idea that they're visually represented differently on this graph. Now, some of you might look at this and think, okay, we've got circles and squares. What's going on here? You'll probably mostly see circles. Circles represent successful executions. But because I was messing around with some stuff before we started, I've got some squares, which means I canceled the queries. Now you could also see in here a triangle. A triangle means I've got an error. But the majority of the time you're going to see circles. And what you're looking for is, what does performance look like over time? So you can see that for plan 8448 and for plan 8284, we had pretty comparable performance at one point, and at another time we had worse performance. But what's interesting here to think about is, what is the metric that we're using to look at? And that's something that you're going to want to pay attention to, because we're looking at total duration. So total duration could be because it executed a lot of times, so total duration's high, or it could be that it executed just a few times, but the duration was long. So sometimes the total metric isn't always the best option. So for example, if I come up here to the configure option, I have a whole set of resource options when I look at Query Store. So right here, top consumers of what? Duration, CPU, logical reads, writes, physical, memory, tempdb, right? Where do you want to go? And then in terms of my consumers, I also have average, min, max, standard deviation, total. So sometimes what's more appropriate is to maybe look at average duration. And I'd argue that duration maybe isn't always the best either, because if you think about how long it takes for a query to execute and you have a scenario where you have blocking, that blocking influences the duration. And so CPU time might be a little bit more accurate in terms of the resources required, right? Resource consumption, when you're looking at performance over time. So we're just going to change this to say still the last hour, but we're going to go to CPU time and we're going to go to average CPU time. So if I go ahead and make that change, this is going to change up the graph a little bit. So if we zoom back in over here on the right, you can see now when we look at averages over time that plan 8448 consumed way less CPU than our other plan 8284. It's confusing when they all have 8s and 2s and 4s in there, isn't it? The purple plan, less CPU compared to the yellow one. Now, what do I know about those plans? Well, Query Store has that as well. That is what is in this bottom window. Let me change this so you can see this a little bit more. But down here on the bottom half of this pane, this is where we have the plan for whatever plan ID we have highlighted. So currently we're highlighting 8448. And if we zoom in on the plan for 8448, we can see that we've got an index seek and a key lookup, and that feeds into a nested loop. I also, you probably notice here, I have a missing index recommendation. So that is plan 8448. I also have plan 8284. And if we zoom in on this plan, it's a different shape. You'll see that here we've got a clustered index scan. That feeds into an aggregate, and then our select. We still have the same missing index recommendation, which is a good thing to take note of. But we have two different plans, likely because we have data that is skewed, and this becomes a plan or parameter sensitive query, right? Where we're getting different plans based upon the input value. But only when we kind of look at average values do we truly understand resource consumption as opposed to using duration and total. Just something to be aware of when you're looking here. Now, this visual, again, is a great place to start. And as I come in here and I look at different queries, let's go up to this USP find orders by description, right? So here you can see, if we just zoom in on this top here, we've got average CPU time and execution count. We've got plan count. And you'll notice, just as an aside, that the execution counts vary greatly in here. The query that we were looking at previously with the two different plans executed 34,000 times. This find order by description has only executed 978 times. But we do have two different plans here as well, which is interesting. We have plan 61, which is our blue plan, which looks to be, when we look at this graph here, right, and we look at where the blue dots show up, in general, average CPU time is higher compared to the gray plan, 8455. So again, we can dig into this in a little bit more detail. We can look at plan 61 and see what's going on in here. We've got a hash match. We can see that we have clustered index scans against these two different tables, and we can see that this runs in parallel. And if we look at plan 8455, it actually looks kind of similar, but it's not. We still have a clustered index scan. We still have some parallelism, but down here we have a clustered index seek, and this goes into a nested loop. So the shapes sort of look similar, but different join types for sure, and different object access. So the thing here about Query Store is not only do we have this historical data that we can go back to at any point and dig into in more detail, we're getting the text information for the query, we're getting the plans for the query, and we're getting runtime metrics. So if I hop back to the configure button quickly and I zoom in again on the different consumers that we have in terms of resources, we've looked at duration and CPU, but depending upon what other challenges I'm seeing on the server, or how the server is struggling, or what's maybe showing up for my wait statistics, I can slice and dice this information a lot of different ways. Execution count is another one that I always think is interesting to look at as well, not just resource consumption like CPU and IO and memory. And another thing that's fun to look at in Query Store is to expand this history. So you'll notice that when I look at this interval, right, again, we defaulted to the last hour. I can be very granular and just look at the last 5 minutes if that's the challenge that's occurring. Or I can go back even further and I can look at the last month, 3 months, etc. Now, the amount of data that's available will depend on how much data I'm keeping. That's configurable within Query Store. But let's change this to just look at, say, the last 2 weeks. And this is another place where, again, I think Query Store shines, because we have this history for plan performance over time that we can go back and visit. And how much data you want to keep really depends on, do you like to play in production? Do you develop in production? Things pretty static, but it allows you to go back in time and look at historical query performance. Now, all of this information is stored in the user database, and we're just seeing it here in these reports because it's really the easiest way to get started. But understand that data is available to you through system views. So if we look at, let's grab a query ID here real quick. So we're going to take This query that let's grab the one that we were looking at earlier, this customer transaction. So this query ID is 8209. So let's change this. So we are looking at 8209. And we're going to pull from many of the query store system views here to look at history. And understand that query store stores information across windows of time. So when we think about dmexec query stats, dmexec query stats has plan query metrics for what is currently in cache. And query store is basically pulling it across intervals of time, like a 30-minute or a 1-hour interval. So when we're seeing this here, we're seeing this information over different snapshots of time based on how I've got this configured here within my database. But under the system views, we've got information like a query ID, a plan ID. We've got the object ID, right? The object to which it's tied to. How many times did it execute? Within that time window, what was the average duration, the average IO? We've got the actual text, and we have the plan. And from this window here, I can just view the plan in a visual graphical format, just like I would if I wanted to pull it from the plan cache. So I've got a few other queries available here. Most of the time, the information that you need will be you can dig into through the reports. But sometimes you're going to want to query those system views directly. And this is an example. This is queries that have executed in the last 2 hours with multiple plans. There presently isn't a report that gives you that type of information, but we can access it directly here. So I can see that this customer orders by date has 2 different plans. I have some ad hoc queries here. I'm not too concerned about those. And then I have a couple other queries from other store procedures. So if I take 55, query ID 55, and drop that into this next query, then I can pull out both of those plans. And I can view those here, right? I can open this one and I can see what that plan looks like. And I can open the other one to see it as well. But what I like to do once I have a query ID, so we've got, again, query ID 55, is we have another report called tracked queries. And so if I enter that query ID of 55 and drop that in, I can see the same thing I saw before in terms of performance over time for the plan or plans with the plan information, but just for this specific query. So here I can see that 55, the plan ID as well as the query ID is 55. I can see that that's the one that's mostly been used, but we also have this 8361, which has also executed. And then I can do some initial analysis from here. I've got a couple other additional queries that I'll just leave. These match some of the views that you see in the top resource consumers, right? So top resource consumers, average duration in the last hour, basically the same report that you're getting when you immediately drop into that top resource consuming report. So those are there for you to explore in a little bit more detail. So let's hop back to the slides. There's a couple of things that I want to make sure you're aware of with regard to basics in terms of query store. I've given you a lot already in terms of why I think it's important. Now just a few details to make sure that you're up to speed on those as well. So first of all, query store is available in all editions of SQL Server and Azure SQL DB. And I say edition meaning standard enterprise edition. It's been available since SQL Server 2016 on-prem. This is a feature that you enable at the database level, at the user database level. You cannot enable it for master, for model, or for tempdb. You can enable it for MSDB. I don't have a case yet why I would do that, but there's probably one out there. If you enable it for model, as an example, you technically can enable it, but you're not doing anything in model. But if you did, then every new database that you created would have query store enabled. As I mentioned, the data for Query Store is stored in tables in your user database. Those tables exist in the primary file group. At present, there's no way to put them in a different file group, and you control how much Query Store data you keep and for how long. So you have settings related to that. As I mentioned, in Query Store, we capture the text of the query, the plan, we get execution statistics. Sometimes I say runtime statistics. I use them interchangeably. And we also get wait statistics in 2017 and higher, and also in Azure SQL Database. You control what queries are captured. So in addition to specifying how large you want Query Store to be and how long you want to keep data, you also have the ability to say what queries are captured based upon internal thresholds and in 2019 thresholds that you can configure. So 2019, SQL Server 2019 and the current version of Azure give you a lot more flexibility in terms of you deciding exactly what queries are captured. And what I mean specifically is that you set thresholds based on CPU and CPU duration, CPU compile, and execution count, or execution count. Actually, they work in an or manner to determine whether or not queries get captured. And this is extremely helpful for those of you with ad hoc solutions. In a stored procedure, parameterized environment, those options aren't really needed. But in an ad hoc one, they definitely are. And with Query Store, the plan forcing can be manual, and it can be automatic. This depends again on your version. This also does depend on your edition. So automatic plan correction is available in Azure SQL Database and in SQL Server 2017 and higher, Enterprise Edition. But plan forcing manually is available everywhere. So since we're talking about, before I talk about plan forcing, I want to mention third-party tools because I know I had talked about, I had thrown that out there originally. And I threw out there that I think that Query Store works with third-party tools. So I want to do a little side-by-side comparison here. So with Query Store, as I mentioned, that is something that you enable for each user database, which means you can enable it for every user database on your instance, but you certainly do not have to. For third-party tools, that's capturing information for all databases on an instance, right? There's, I can't think of the right word. There's no bias, right? They're collecting everything. Query Store allows you to configure collection options, so do third-party tools. The retention size in Query Store, which you control, will affect the size of the data that gets stored in your user database. With third-party tools, that data is stored in a separate database. So you still control retention information, you still essentially control how large that data is, but it's in a separate database. Query Store doesn't capture runtime parameters. And what I mean is if we execute a stored procedure with a customer ID of 401, and then we execute the stored procedure again with a customer ID of 5008, 401, 508, those are not stored anywhere in Query Store. Obviously, when the plan for that query is compiled on its initial execution, whatever parameter was used then is stored as the compiled parameter, but the runtime parameters are not captured. They can be captured by third-party tools. I mentioned that in SQL Server 2017 and higher in Query Store, wait statistics are captured, and those are query-level wait statistics. So not the same as what happens if you run a query and you look at the actual execution plan and you get wait statistics in there. This is the same level that you would pull from DMExec session waits. Now, in third-party tools, you're getting instance-level wait statistics, so two very different sets of information. Query Store, again, is available in 2016 and higher. Third-party tools, multiple SQL Server versions, right? Going back to if you're still running 2008 R2, yes. Those of you who are not quite on 2016, right, but are eyeing Query Store as something that you definitely want to use when you get there. In earlier versions, there is a tool called Open Query Store. It's available out on GitHub. It's developed by some fine folks in the SQL community, and it uses either service broker or agent jobs to capture information from the DMVs. And it works similar to Query Store. It's not exactly the same, but it's a good place to start if this is something that you want to go to when you upgrade. And the last difference between the two, which I think is a big one, is in Query Store, you have the ability to force plans. And in third-party tools, you do not. And the forcing is the second biggest reason to me why people need to use Query Store. So if we think about query performance, and we know we've identified a query that's not ideal, right? That's running poorly. How do we address that? What do we do to fix that? And ideally, we change the code or the schema, right? We fix the problem at the source, at the root. Now, for those of you that have third-party tools or third-party applications, I know you're probably thinking that's not an option. And I get it. And that's why Query Store is so great. So stay with me. For those of you that have applications that are developed in-house, you can go to the developer and you can say, hey, this is something that I need to have fixed, right? Now, that may not happen as quickly as you want, and plan forcing can still help you here. But that's ideally how we're going to solve those issues. The quick fix, the quick fix that's not actually addressing it through changing code or schema is a recompile, right? We throw a recompile on the query. Now, depending on how frequently that query runs, that might not be a large hit overall to our system. But if it's something that executes hundreds of times a minute, maybe it is, because every recompile increases CPU, right? We've got compile time in there. That can affect query performance and overall system performance. So it's something that there are cases where it can be used, but it's not a blanket solution. Hang on. Excuse me. Now, we also, when you have to try to get creative to look at performance and how to stabilize it, we can try and get the best plan in cache manually. And I don't mean manually by sitting at Management Studio and pushing it in there. I mean, we create an agent job, and the agent job runs every few minutes. And the job looks to see what plan is in cache for a particular query. And if it's not the plan that's the best plan, we're going to remove that plan from cache, right? Not drop all of cache, just selectively remove that plan from cache, and then immediately run that query with good input parameters to get the good plan into cache, right? It's a complete and total workaround, but it's a way to temporarily address a poor performing query until you can do something longer term, right? I don't want to give you any ideas if you've never thought of that, but I've seen it used, I've seen it work. A lot of folks will say, well, maybe we just need to update stats to fix the query. And there are cases where you have a lot of churn in your data. Maybe you're loading data into a new system, or maybe there's just a high volume of data being added, or maybe you have tables that have a lot of inserts, updates, and deletes, right? That's what I mean by churn. In those scenarios, updating stats is absolutely essential because we need to make sure the optimizer has the latest information. But what I don't love, why I put a red ant over this, is because what I very often see is something isn't performing well, people think it might be statistics, they update stats, and then the problem is resolved. And what likely happened in that scenario is that updating stats caused the plan to recompile, and so then we got a better plan into cache. So that to me isn't necessarily always the right long-term solution. Depends on the problem that you're running into. Now, some of you may have great experience and have been very adventurous in the past and used plan guides, and I salute you if so. Plan guides are absolutely an option for guiding the optimizer to what plan to use for a query. I find them a little finicky. I don't find them intuitive, but they're there, and they're still there and they work. But plan forcing is the new thing. And this is extremely easy to do. So let's come back to our demo and take a look. I'm going to grab a drink real quick here. I know it's a black screen, don't panic. I just need to click on this over here and bring that up. There we go. Now, I'm going to start where we left off before with this top resource consumers query. Top resource consumers report. And let's say that we've been looking at this customer transaction info store procedure, and we identified that with the 8448 plan ID. Remember, we had this index seek with a key lookup going on, right? With a nested loop in here. So we have this plan. And then we also have our plan that is the clustered index scan. And when you're hopping back and forth between plans trying to do some comparison, this is a really easy set of plans to look at, right? But if you have more complex plans, not atypical, what you can do is you can hold down your shift key, and I'm way over here on the right, and I held down the shift key and I clicked on both the plans. So you can see that 8284 and 8448 are both selected. When they are both selected, we have this option up here that I'll also zoom in on, which is compare the plans in a separate window. So I love that I can do this right from Query Store, right? In other scenarios, I have to save one plan out and then open it. Here, I can do it right from Query Store. So now I've got a top and bottom 2 panes that I can compare and look at performance to see, okay, or I can look at the plan, right, to see what are my differences, what might I want to do here, what plan might I want to force. So we can look at this and we can say, I'm going to make a quick decision, right? I'd typically do a little bit more analysis. And I'm going to say, okay, we're going to go with this index seek and the key lookup. We're gonna work with that plan. So I've got that plan highlighted, and to manually force, all I need to do is say force plan, and it says, do you want to force plan 8448 for query 8209? And I say, yes, I do. And I come in here now, and when I look at my plan, I can see that this one has the check mark because that is the one that has been forced. So that is the one that will then be used moving forward. So manual plan forcing is very easy. And something that's a report that's very useful that I'll point out is this queries with forced plans report. So at any point in time, if you want to understand for a database, what queries do I have that force plans? This is where you want to go. And you, again, will still have all the history for that query. This is giving us information for the last month, which I don't have in this scenario. But we can look at, again, performance over time for a given query. So plan forcing, really straightforward. All I have to do if I want to unforce that at any point, let's say that I identified that I need to create a non-clustered index to address this, right? That's really the long-term solution here. That's the schema change that needs to happen. But we have to go through testing, and it has to go through testing in QA and user acceptance before it gets into production. Okay, in the interim, I can force my plan. Once I drop that index in place, or right before, I can go ahead and unforce. So I just click the button over here. Let me zoom in really quick. And I'm going to say unforce plan. Do I want to unforce that? I do. And that's gone. So I view plan forcing as a temporary solution. You can definitely use it long term. But I don't think it's a set it and forget it, because databases are living, breathing entities and they change, right? The data changes, code changes. So I think that plan forcing is a fantastic option to use to help stabilize query performance. But I want you to pay attention to what's forced and understand that maybe over time something might need to change. Now I'm going to close out of this window as well as my original query window. And we'll go ahead and open this other set of queries that I have. And I've already restored this database that we're going to use. It's another copy of Wide World Importers. And we're going to go through a couple steps for setup here. First of all, we're going to make sure that we turn Query Store on. And I'm going to set some options here, which are great for my demonstration. They are not great for your production environment. So these are just for demo purposes. And I'm also going to run this query, which is just for demonstration purposes, which is I'm going to clear everything out of Query Store. This gets rid of all of the data that was in there. Now, I'm going to look at two views that are going to let me know what I have configured for this database. And let's make sure that I'm in the context of my wide world importers database. So we can see that I'm most interested in the second output here, which is /good plan. And you can see that the actual state of this is off. Now, if you're in Azure SQL database, your output will look slightly different. For my on-prem database, this is what I get. So my automatic plan correction right now is disabled. We're going to turn that on. So alter database, set automatic tuning /good plan on. This is going to enable automatic plan correction. A little bit more prep that I need to do. We're going to push the customer ID into not a temporary table, it's a persisted table. So all of the unique customer IDs from the sales.customer transactions table, I'm pushing those into this customer IDs table. And then I'm going to delete from there 1 and 401 because I will tell you that customer ID is a very skewed value. For the values of 1 and 401, I have about 500,000 customer IDs. And for every other customer ID, I have about 3,000. So this is very purposefully a skewed distribution and a scenario where I know I will get different plans based upon different input parameters. So we've removed those 2 rows from there, right? Let me just make sure I've done that. Yes. And then this is the stored procedure that we're going to use, which looks a lot like the one we were looking at previously, right? We're going to get the customer ID and we're going to do a sum of amount excluding tax from the sales.customer transactions table for a particular customer ID and then group by a customer ID. So very simple stored procedure. And then I'm going to kick off some scripts in the background that are going to run that. So basically, let me just open up and show you what script I'm calling. It's basically calling this stored procedure first, which this is a customer ID that only has about 3,000 rows. And then we're just going to loop through and run this stored procedure over and over for all of these different customer IDs except for 1 and 401. So if I open up Query Store reports for my wide world importers B database, and I look at top resource consuming queries, and again, I'm going to just switch to the grid view because that's what we've looked at the most, right? This has already executed over 4,000 times, and we have one plan. And if we look at that one plan, it has a plan ID of 7, and we zoom in on this, we can see. Oh, well, I love it when things switch like that back to my slides. Hang on, there we go. I clicked off of that screen. That was what happened. So here, this is the plan. It's an index seek with a key lookup because, again, this is a more unique customer ID. We don't get a lot of rows out of here. So here's what's going on, right? Again, I have automatic plan correction enabled. I'm going to create a regression. And all I'm going to do with this create regression command, I'm going to open this up so that you can see it, is it basically clears the procedure cache for this database, and then it runs that stored procedure with the value of 401. So remember, I said 401 is about 500,000 rows. So this is going to create a different plan. So we'll go ahead and run that. And once this shows up, then we'll flip back to the top resource consuming queries and take a look at what we have there. I think my laptop is a little bit tired. It's thinking about it. While that's going, there we go. So there comes our queries in here. And if I come back over into this view, I'm going to refresh. And what you will see, now I'm going to zoom in here. What you'll see is that Plan ID 7 now has a checkbox. I didn't manually do anything in terms of plan forcing. This happened automatically. So if I look at Plan ID 46, you can see that this is a clustered index scan. So when that non-unique customer ID of 401 came in, right, we purposely cleared the plan cache and then ran it with that value. It said, oh, for this value, I'm going to do a clustered index scan. And what happens is that query store, SQL Server, says, hey, we have a regression here. This is not great. We're going to go back and we're going to force the last known good plan. Now, when you look at this graph, you're probably thinking, hold on a second. Plan ID 7 is way up here. And plan ID 46, which is my clustered index scan, is at the bottom. Remember, by default, we're looking at total duration. So let's see what happens if I change to CPU time and then average. Right now, when we zoom in on this graph, right, the average CPU for plan ID 7 is significantly less than what we had for 46. And that is what Query Store and SQL Server use to determine if there's regression is CPU. And if we look in the system views, we can see this directly. So this comes up in DMDB tuning recommendations. And I'm just going to go ahead and execute my pretty query against that. And so you can see that this regression occurred because average CPU time changed from 15 milliseconds to 168. So that crossed the internal threshold in terms of performance, and SQL Server said, hang on, we're going to go ahead and we're going to force. So it gives me the regressed plan ID, it gives me the forced plan ID, it tells me when this occurred, and notice that it's still in a status of verifying. So automatic plan correction is not a set it and forget it. There's a built-in process of when it forces a plan, it then continues to monitor to make sure that that plan doesn't regress or that it doesn't fail. But it will continue to use that plan until it fails or until there is a schema change or until there is an update to statistics. So it's a continual evaluation process that occurs. And the script is here in case you want to force the plan manually. But if it's forced automatically, it can be unforced automatically. That all gets handled within the engine. Now, if I said, oh, remember there was this non-clustered index in there that was recommended, what happens if I go ahead and create that? Because that will help that query, and regardless of what input value I have for customer ID, we're going to get a much more stable plan across all values. So let's refresh this. Now, what happened in this case, I love it when my demo doesn't go as planned. So what's happened here is that the plan is still forced. That was a schema change, and that should have caused it to unforce. So let's do this again. So I'm going to go ahead and drop that index. Great. We'll go ahead and recreate it. And let's refresh one more time. There we go. So now what we see, you'll see we now have a new plan ID, 60. And plan ID 7 is no longer forced. And if we look specifically at plan ID 60, this is an index seek, and this is going to be against that non-clustered index that we just created. So if I hover over this, you should see that that's what we've got going on, right? Here is that SQLskills index that we created. So if there's a schema change, an update to stats, a failure in the forcing, that plan would automatically be unforced. So in addition to plan forcing, in addition to the historical data, another reason that I recommend using Query Store is because of the testing. You've got built-in information within your database that you can now use to test your upgrades, whether it's a hardware upgrade, a software upgrade, a version upgrade, whether you're looking to test changes in the different cardinality estimators. Maybe you upgraded to 2017, maybe you needed to stick with the legacy CE, and after a few months, you're thinking, all right, time to try the new CE. Right? You've got all this data in Query Store, you make the change, you continue to capture data in Query Store, and you can do comparisons. Same with compatibility mode. In fact, SQL Server, Microsoft really wants you to get to the latest and greatest compatibility mode, and they have built an automated option here with the Query Tuning Assistant, which is part of Management Studio, to help you test compatibility mode and figure out if changing that is going to be effective for you. And again, for code changes as well. So you have all of this information, all this data captured already within your database that you can use for additional testing. Now I have a few recommendations, and before I hop into my recommendations, I don't know if you can hear my fan just whirring away in the background because I'm running these queries over here. So I'm just going to stop those to make sure that we're not getting any kind of interference there. My recommendations, and these are very broad with regard to Query Store, is first, run the latest build of your release. Query Store was released in SQL Server 2016 on-prem. It had already been in Azure SQL since late 2015. And it was really fine-tuned based on a lot of telemetry captured. But not every workload exists in Azure. So there had to be some workloads that were on-prem that obviously exposed some challenges related to Query Store. The team has continued to implement fixes and improvements, and so the latest and greatest cumulative update is always where I recommend you be. There are multiple settings related to Query Store, and two of the most important are the query capture mode and the max storage size. You want to make sure those are properly configured, and I have a blog post that I reference at the end that talks more about those options. Use trace flags 7752 and 7745. 7752 is enabled by default, is enabled as part of SQL Server 2019, but anything below that, you want to make sure you've got both. As I said when I talked about forcing, make sure that you're monitoring your forced plans. It's not just set it and forget it. I want to take a look at those over time. And then be aware of the impact of ad hoc workloads. And if you're thinking, hang on, you haven't said anything about ad hoc workloads. I kind of mentioned it a little bit when I talked about the settings. And remember that a lot of folks go with stored procedures, with parameterized queries, right? Where the statement is the same, the text doesn't change, the input values are parameterized, and we get good plan cache usage, right? Plans get in there and they get reused. And just as a quick example of what some of that code looks like is, right, we have a variable declared, we set the value for that variable, and then we reference that in the query. So here I'm setting color name to blue, and then in our predicate, we have @color name. We can do this with customer ID, right? We've declared a customer ID, we've set that to a value of 3248, and then in our predicate, we reference that. So that's something that a lot of folks I know use and work with. But I also know that there's a lot of folks out there that have ad hoc workloads where the statements have a different text, right? Different literal values in the predicate for every execution, which means that these are identified as unique queries within the Query Store, within the plan cache and within Query Store. So as an example, I have that similar select to what I had before, but rather than a variable or a parameter, I have where the color name is blue, or where the color name is red or purple or whatever value. With a customer ID, where the customer ID is 3284 or 401 or 1108, right? Every single query has a literal value and they get recognized individually. If you're not sure what kind of workload you have, please take a look at this post that I have on SQL Performance. Kimberly also has a great post that talks about the plan cache and optimizing. And those workloads, those ad hoc workloads, can be a challenge when you enable Query Store. And those workloads have their own set of challenges, right? Related to the plan cache, related to compilation, related to CPU. And they can also be problematic with Query Store because of the number of unique queries and plans that have to be retained. Once you get to 2019, that's where things get a little bit easier because, as I said, you can control configuration. But that is something definitely pay attention to when you're looking at using Query Store. Now, I covered a ton of information, and if you're thinking, ooh, is this a feature that I should use? I'm going to say absolutely yes. You do not have to be an expert in tuning to use Query Store, right? This tool was designed so that anybody can use it. You can find the worst performing queries, you can find regress queries, you can force plans. If you're somebody who's been tuning for a long time, you're going to look at this and you're going to say, oh, I got this. I understand what's going on here. And you're going to start thinking of ways to leverage all this information that exists within Query Store. And you'll find that there's a ton of things that you can do beyond just these few things that I've talked about today. So why do I think you need Query Store? Well, first of all, it gives you historical performance query information that you can look back over time to look at performance, to understand patterns, right? This is built into SQL Server, and you have the ability to manage what's captured. You have the ability to do plan forcing, whether you do it automatically, whether you do it manually. Automatic, again, depends on your version and your edition. Manually available across the board. You have the ability to do A/B testing, right? Before and after testing for hardware, software, cardinality estimator, compat mode, right? Tons of options exist. And I didn't even get to this today. You can proactively analyze your workload because all that data is stored in there, and you can go through and mine it, looking for patterns in what developers are doing, in plans. It's a plethora of information. Understand that new functionality in SQL Server will continue to build on Query Store. This is not a feature that's done. It continues to evolve, and I'm really excited to see what the team continues to do with this in the future. So I hope that you found it as interesting and as valuable as I do. I've got a bunch of resources here. I've got blog posts. Some of them are very specific that I have on here. Best practices for Query Store, performance overhead, some requests that have been made. I like to share those with the engineering team every so often. And then I've got just a ton of posts in general related to Query Store. If you want more information, I've got 2 courses out on Pluralsight. One is an introduction to Query Store. The other talks about the automatic plan correction in more detail, along with the additional functionality that was added in 2017. Thank you for tuning in today. I really appreciate you joining in. And if you've got any follow-up questions that didn't get answered, please feel free to send me an email, Erin@SQLskills.com. Thanks for being here.